Hello and welcome to another video. Let's go through the aircraft parameters. I'll drag a plane into the level. The first section is the aircraft setup. You can change these in the blueprint to apply to all the instances, or in the level to apply only to this instance. The first one is the scale of the aircraft compared to the original meshes you've imported. You can keyframe this in the sequencer. Let's open a sequence to see which of these are keyframeable. The parameters with this icon are keyframeable. Next, we have rotation multiplier and max angles for ailerons, elevators, and rudders. When I change the plane's roll, these ailerons rotate. If I need them more sensitive, I can increase the rotation multiplier. Let's set it to 5. See how much faster these will rotate. We also used this parameter before, when we set up the plane, to correct the reversed rotation, remember? And then there is a max angle for the rotation. Let's increase it to 50 degrees. We have the same settings for the elevators and rudders. Let's try these as well. You can see the difference between rotation multiplier and max angle. Set these values based on reality and how your aircraft works. Next is the editor update toggle. If it's on, the blueprint will constantly update in the editor. If I turn it off, it will not, and you have to play or simulate. Next is the FPS for editor update. This is only for visuals, and when you hit render, this editor update function will be out of the cycle. Next is the visibility toggle, and it also affects the render. When I turn it off, the billboard is back again, but it will not render, so don't worry about it. It's just there so you can find your invisible aircraft better. The next category is flying. Let's draw a path quickly. The path drop-down will list all the compatible paths in the level for you. You can select any of them here to attach your aircraft to it. You can also keyframe this path parameter and switch between paths in your sequence. I'll animate the plane along the path to show the effect of the next parameter. The response speed sets how fast the aircraft will align to the path. When it is 5, you can see how it aligns rotation with a delay. When I decrease it, it will align much slower. When it's 10, it will be instant. Because splines can have choppy curves, I recommend keeping this below 10 for smoother aircraft rotation, but it's your decision. The next one is the path side offset. You can offset your aircraft sideways from the path with this parameter. This is in centimeters, so 100 for 1 meter to the right. And 500 for 5 meters. And the next is the height offset. You can offset your aircraft vertically with this one. A use case will be for vertical flying aircraft like a hot air balloon or a helicopter. You can keyframe it to change the height of the aircraft gradually in your sequencer. The next is the align to the path. It sets whether the aircraft should match the pitch with the path or not. Keep it on for planes, but turn it off for hot air balloons or helicopters or any aircraft that needs to be vertical. You can see if it's on, it's obviously wrong for a hot air balloon. A hot air balloon should always be vertical, so I'll turn off the align to path. Let's bring back the plane. Next is the detach from path. As long as it's on, your aircraft cannot be attached to any path. You can also keyframe this in the sequencer, but you need to keyframe the path parameter as well. When it's red, it's not detached, and when it's green, it's detached. The distance traveled is pretty self-explanatory. You can keyframe the distance of the aircraft from the start of the path with this one. It's the main parameter you use to animate your aircraft along the path. The next one is the distance offset. It works like an additive to the distance traveled track. You can use it to quickly correct or adjust the distance on the path. And also, it can be used to quickly give some movement boost to the aircraft. The next three are extra rotations. You can add and keyframe extra rotations around any axis. Not all of these are needed for every aircraft type. For planes, you only need to add extra roll at curves if you want. For a helicopter, you'll need extra pitch and yaw. The next is the wheel rotation toggle. You can see when it's on, the wheels will rotate. I'll keyframe the wheels rotation toggle to show you another thing. I'll turn it on here, and turn it off here. You can see when I turned it off, the wheels did not stop rotating right away. That's because they have to rotate for a while before stopping, so it'll take time for it to stop. The next one is the propeller's speed. You can set it negative for reversed rotation. Please note that the propeller's rotation depends on your render FPS and temporal sample count. So, you need to do some test renders to figure out this number for the best motion blur results. The last one is a toggle for doing a vertical loop. Let's switch to the demo level. This is called a vertical loop. When the plane is about to enter the loop, we should keyframe and turn on the vertical loop toggle. And when it exits, we should turn it off. Let's see what happens if I don't use it. When the plane passes a certain angle, it will rotate to the other side of the spline. I don't know why splines in Unreal behave that way. Maybe there's an explanation for it. But I tried to tackle this problem with some tricks, so make sure you enable this toggle whenever you want to do a vertical loop. That wraps up the flying section. The next section is the read-only. It contains the speed in kilometers per hour. And the last section is the body noises. You can add air turbulence or any other vibration you want to your aircraft here. First, let's increase this overall body noise because it is 0 by default. I recommend you use this feature because it adds a lot to the realism of your animations. We currently have 3 types of body noises: height, roll, and pitch. I'll isolate the height noise so you can better see it. Some of these might not be relevant to some aircraft types, so I have separated them so you can add any of them you want, based on your aircraft. Each of these has an amount and speed. If I rotate this plane, you can see this height noise is in local space, not the world space. There is an amount in centimeters. And then there is the speed of it. The same goes for the roll noise. The amount is in degrees. Also, there is a speed for roll noise. And lastly, there is the pitch noise. It is not relevant to planes, but can be used for helicopters and hot air balloons. And with this overall multiplier, you can control all the noise amounts, all at once. There are 2 parameters here to control the time. If the user-defined time is off, all the noises will run continuously on game time. But since these are per-lin noises, they can lead to different results each time you render. If you are rendering multiple passes of the same animation and want to composite them later, or you want to stop your render and render the remaining frames later, you'll need the same noises each time you render. In that case, you can use the user-defined time for the noises. If I turn this user-defined time toggle on, the noises will stop. Because now, this time parameter is our time and currently it is frozen at 0. If I keyframe it and increase it, the noises will run again. To make the noises the same as when the user-defined time is off, we need to keyframe this time parameter in seconds. So, here's what we do. First, I will turn this user-defined time off, so I can visualize the noises. When I set all of the noises how I like, and maybe keyframe them throughout my sequence, I'll turn this user-defined time on again. Then I will keyframe the time, set the first keyframe to 0, and maybe make it linear. Then I'll go to the last frame of my sequence and calculate the time by dividing the frame number by the sequence FPS. 150 divided by 30 here results in 5 seconds. So I'll set the last keyframe 5. Now when I play the sequence, the noises are back again, but this time, they are non-random. Let's check that quickly by exaggerating the noises. You can see when I go back and forth between 2 frames, the noises repeat and they are not random anymore. That's the end of this video. I hope you've learned something from it.